Blue line.
Just count me in. I'll
3, 2, 1.
June 14th, 2023. Welcome to Live Coding with the Gimbal Labs and the PBL, Plutus PBL.io. If you are listening on YouTube now or in the future, you can come over to our Miro board and Zoom room, which is linked on maybe gimballabs.com and see this wonderful free course. You can learn along with us, Dan, Faizan, Harsha, Claudio, James, and myself, Newman. And so we have a pattern here where we go through and talk about what we want to cover on this Miro board. You're looking at it right now. We just take a few minutes to quietly put things down, and then we decide with a vote in Miro board where the camera stays, and we also do things into a breakout room so that some folks break out into a different room to work on their stuff as we work through this wonderful course. Anything else, James, to get us started?
Intro. Thanks, Newman. You were, before we went live, you were asking folks for different updates, and I think Dan, did you want to grab that mic?
For sure. Let's keep it going. I can start off with, I got really involved with Docker and Nix and all of the other little things and setting up the dev environment. I just hear it over and over, like getting the dev environment is like the hardest thing. And I'm like, is that true? And then it is kind of hard, and you'll get it going, but if anything gets out of place, then it's all messed up. And then I realize that I don't have a firm understanding of what's exactly going on in there. So I really wouldn't mind learning about some of the secondary tools like Nix and well, we don't actually use Docker, I don't think, but Cabal and what are some of the other like secondary, and then just the command line, just like some Linux, things. I'm using a Windows system, and it's got WSL, which is Windows subsystem for Linux. And that kind of throws some monkey wrenches around. So I wrote those things down somewhat, and I'm curious as to what other folks have got. I know that Faizan, you want to jump on and talk about what you've got? Or Harsha?
I'm still at minting NFTs. I'm still trying to figure out like the reference UTXO in the minting transaction, specifically for CIP25. So I'm still trying to figure that out because we did it in the last session.
Oh. That's right. Okay, hey, Faizan.
Yeah, I'm also still on module 204.4 reference UTXO. So in middle, I just decided to write smart contract. So with Newman and Harsha, we were trying to install the Nix on WSL, but we were facing some issues related to the Nix shell. So let's see where the path goes.
And and I save those. One of the fun things that we do is, oh my goodness, I'm looking at my visage here. One of the things that we do is save our error messages. Going through the course, you're going to run into error messages, and it's one of the nice things to have someone troubleshoot. So we've got some error messages to troubleshoot, and I can copy those in at the appropriate time. Basically when running the nix-shell command. And I may, we'll see. Dan, you weren't. What's on your mind today?
Not too much. I took a break last week because I couldn't find the meetings in the calendar, so I figured I'll just take some time out. So I did, yeah, I'm just in the process of upgrading my node to version 8, but
Oh,
waiting to or waiting for the download to finish. So I'm not going to restart my computer in the middle of the in the middle
Probably
of the
good.
session, though. So because there's some other updates from Linux as well waiting. So then I run a laptop with Linux on it, so I don't have the problems of
Right.
Windows,
Yeah.
or anything like that. So your thing saying about the Nix shell, I had great fun, and this is running native Linux Ubuntu on my system. I got 16 gig of RAM, and when I first tried to run it, I tried running Nix develop, which kicked up the error about flakes and develop being a new command. So you have to put a switch in for it. Ran it, failed, ran it again, failed again. Thought, I'm giving up on this. Tried Nix shell, ran Nix shell. That failed. Tried to work out what was going on with it, ran it again, and it worked.
okay. Yeah.
This is really weird.
Yeah.
What's going on? Tried Nix develop, and that then worked. So I think it was just, it's obviously exceedingly resource hungry when it's
Okay.
building whatever it's
Okay.
building. And I think it was getting so far falling over, but because some of it had already been done, it didn't have to redo that. So it then got a bit further and finally ran in the end. So that could be something to try. Just keep going at it several times and see what happens.
It's funny, like the mindset or the mental model. It's just like sometimes you just have to smash at something a few times and then to get it to work, right? You work on a boat, it's just you've got to do it a couple of times and it doesn't work, and then just randomly it does work. I think you may be right. It's just each time it gets a little further, or something like dependencies or some, the keys on the lock kind of like somehow like roll together and it works. Okay, so yeah, maybe I just have to continue to do it. And I did find some of the documentation, and I'm going to paste that into the mirror board, basically around those command Nix develop, and they have a pretty good reference here in their documentation. So thank you for that, Dan.
This is connected to anybody who's had trouble getting any of the projects running in Demeter Run. You're running up against a resource limit the first time you build something. And so one solution that we had at our disposal, and we did this earlier in the course, is the Demeter team was able to create a cache of the Plutus repo that we were using to introduce Demeter and Plutus. But you might more recently have run into this resource problem again, because I'm overdue in asking that team to update the cache now that the Plutus repo we're using has changed. So that I need to just put in that request, get that updated. But it's not satisfying. To know that like the answer is, hey, to do this locally, just try 3 times. Right. Everybody in the long run, let's try to figure it out.
Well, I get, and James, maybe you can enlighten us about the, there is this program is meant to put us into, it's not really about learning to program. And this is for me personally, I guess, but something that resonated with the program. It's about like the troubleshooting and figuring out, like you say it in an elegant way, but there is this thing about like figuring things out as like the real goal or an objective, one of the objectives of the course. But do you know what I'm talking about? Is that a familiar thing? Oh, dang it.
Without a doubt. No, of course it is. I mean, you know, we could talk about building mental models, right? Just having the experience with any of these lessons, any of these mini projects. No matter what your end goal is, you're going to have a better model of what the shape of Cardano development is, right?
Yeah.
And so that matters as much, at least as much for project managers as it does for devs. So some people might take this course with the end goal of just being a developer, and that's great. But also we hope that this course it is valuable for a broader audience, right? For example, people who want to be project managers. You know, it's really good if you understand the high level architecture. You should know what UTXOs are. And one of the best ways to understand UTXOs is, yeah, to get in there and build transactions the hard way, even if just for a little while, right? With Cardano CLI.
Yeah.
So I hope we're validating that hypothesis. And then, of course, the other thing that happens when we learn together, we're just building up trust right here.
Yeah.
Right? Whatever opportunities come the way of this group over the next 1, 2, 5 years, this experience of learning together, I think, is preparing us for other ways we might choose to work together in the future.
Building trust, learning together. Yep.
Yeah.
Yep. So it looks like we've got some things to vote on for where the camera goes. Like these breakout rooms can happen. We can decide, what has happened. I think we're at the voting stage. Everyone agrees that we're at the voting stage of our pattern. We're about 30 minutes in, so if we get a couple minutes of voting, maybe a minute of voting, and we've got a small group. Then we can decide where the camera stays. Now we got to vote. We've got in breakout room 1, troubleshooting dev environment setup and reviewing the tools that we're using, sort of a high level thing. Breakout room 2, why do we need reference UTXO to mint SIP 25 NFTs? What is a reference to UTXO? That's breakout room 2. Breakout room 3, error messages, getting error in Nick shell. Breakout room 3, that's breakout room 3. And breakout room 4, module 204, step 4, unlocking UTXO from the contract address. So breakout room 2 and 4, pretty directly related to the course material, specific stuff. 1 and 2, maybe 1 being really high level and 3 being general, or specific to this Nick shell, which is somewhere in the course too. All right, let's vote.
I think we should combine the breakout room 2 and 4, because in module 204 we will come with reference UTXO.
Yeah, they do seem to be pretty similar. Let's see what happens.
Yep.
And if anybody's not in Miro, just drop a number 1, 2, 3, 4 in the chat here.
Oh, do we get 2 votes? No. 1 vote. Oh yeah, and if you're not in the Miro, please put it into the chat. Looking at the chat. We could Sybil attack the live coding vote. That'd be awesome. Okay, it looks like there are 3 votes for breakout room 2, working with the SIP 25 NFT and the reference UTXO. I like that one. That one's cool. And 1 vote each for 3 and 4. I think we can keep the camera, and maybe, I guess James goes with the camera.
Often, not 100% of the time, but it has usually been the case. I'm happy to open these breakout rooms. Does anybody want those open? I'm just asking because we have a relatively small group today.
Yeah, I think we can. I'll stay in the same room.
I'll,
Hmm.
oh gosh, hold on. Pardon me, I have the window open today. It gets a little loud in here. I'll make 2 breakout rooms. I'll call one of them dev environment plus error
Yeah.
message.
Yeah,
And
actually,
so
that'd be good.
got
I'll,
those just in case.
I think I'll stick around. I know that Harsha wants to stay in room 2 and Faizan as well, because those two fit there. I might stick around, but if I get my eyes glaze over after some time, then I'll pop out and just to work on this dev environment stuff. It's now 11:01 Eastern time. We've been at it about 30 minutes. So, and I think that's about par for the course. So we'll go for another hour until noon, and that will bring us an hour before the Project Catalyst town hall and some other stuff. Okay. All right.
Awesome.
Thank you much.
Yeah, thanks, Newman.
welcome.
Yeah, would anybody be interested in leading this exploration today about minting and trying to unlock some UTXOs? Oh, Harsha, it looks like you're talking, but I can't hear you. Oh, Faizan.
Faizan, yeah.
Hey, Faizan, you in?
Yeah.
All right.
Yeah.
Take it away.
So you'll maybe share your screen, and do you have access? There we go.
Yeah.
And which of the module 204 step 4? I can put that link in the chat if everybody wants it.
And I guess I think the thing that got the most votes too was also before even getting to 204, do we want to look at the NFT minting and this question about why we need reference UTXOs there? I'm happy to go in any order.
Yeah, that might be because we're going to run into that real quick, right? That's pretty much the thing of it.
And just checking here. So that's in module, it starts in module 203, the NFT question, right? And there's an assignment about minting the PPBL NFT.
204 step 3.
203.3.
Oh,
Yeah.
203.
Yeah.
So should we continue step 4 with module 204?
Maybe let's what we're talking about is going back, because this is sort of foundational to that one. So we'll start here at if we're agreeable, start at 203 step 3, which is the assignment meant the PBL to 2023 NFT.
Okay, this
Exactly.
Yeah.
And there's a provided shell script here. I just dropped the direct link in the chat. So you can see it on GitLab, but Faizan, I also know that you've got VS Code there. But you see down below, you can find the link.
yeah, I got it.
Yeah, you got it. And just to orient us to the original question, can you scroll down to line 100 or so?
Yep.
Yeah, you see, we're minting something, right? So this lines 100 through 104 are the minting part. And this is not the only way to mint, right? It's possible to mint using a native script. And that concept is introduced in module 202. All right, so you see a bunch of different ways to mint just generic tokens. So we don't care in module 202 if they're NFTs or not. Then in 203, yes, we add the NFT part, and the NFT part in this case is separate from the minting logic itself. Okay, we can basically get a SIP25 NFT by including line 106. Right? As long as you throw the right transaction metadata on the minting transaction, you can end up with a SIP25 NFT. But that NFT could still be minted by two different methods. Maybe you can use a native script to achieve it, right? A simple, right? Not Plutus, and you've seen native scripts earlier in the course. We can go back to those. But here we're doing it the other way. This is being minted with a Plutus script. Okay. Okay, so if we're going to mint with Plutus, that has no impact on line 100. Line 100 is going to look the same no matter what minting method you're using. It's just going to say mint this quantity of this policy ID with this token name. Right? But depending on the policy ID, we're going to have to meet the minting requirements. So some policy IDs are derived from native scripts, as I just mentioned. If that's the case, we're going to use a native script. This policy ID is derived from a Plutus validator. And so now we have to validate with that. So far, so good? Okay. Now, if we are minting with Plutus, you have two more methods, right? So maybe you're starting to have like this branching diagram in your head, and we could draw this back on the Miro. But right, I can mint by either native script or Plutus. If I'm minting with Plutus, now I can use either an embedded script in a transaction, right, by uploading the CBOR in the transaction itself, or to save on transaction fees, I can just use a script that is already deployed on chain, line 101, a reference TXN. Any questions at this point?
Yeah. Harsha, Faizan?
I'm still wrapping my head around what James
Good,
said.
good.
I think,
So,
yeah, I think when we use reference UTXO, the amount which we have to pay, it's get declined. Is it like that?
Say that one more time. I want to make sure I'm hearing it right.
When we use reference UTXO, the amount which we pay for minting, it is not in use. Means we don't have to pay anything for it.
Good, very good. Okay. You will ultimately have a lower transaction fee if you're using a reference UTXO. And everybody here, any student using this script right here, doesn't need to do anything. You don't need to take any action on the reference script itself. All you're doing is referencing it. Okay.
Okay.
Now let's in some ways going a little deeper is going to make this easier to understand, because I think it can help to really talk about some of the advantages of this approach. Okay, so let's zoom out again. But actually, we were talking earlier in this meeting about starting from the beginning, right? And here's a case. Let's kind of go through some of the prior things we know in order to build up what's happening here. First of all, when you first learned about how to compile Plutus, you compile to that CBOR script, that .plutus file, okay? And from that file, in this case, we can build a policy ID. And if I wasn't using a reference UTXO, forget about transaction costs for a second. If I wasn't using a reference UTXO, but I wanted somebody else to mint with that Plutus script, I would have to somehow share it. Yeah. It's not hard to share it. I could put it in this Git repo and say, hey, copy and paste this or download it or something, right? But it's still an extra step to share that script. Here, instead, all you need is a transaction hash. You don't need the whole script. You don't need the whole CBOR. All you need is somebody to tell you, hey, the script you need is on chain already. And here's the UTXO that has it, right? So I think of that as incrementally easier than passing Plutus around or needing everybody to compile it. Dan, what do you think?
I was just thinking, I don't know if this will help clarify. I think Faizan, I'm not sure. Are you thinking that the mint.tx in reference UTXO, it's a reference as opposed to a UTXO that is being spent in the transaction? So the TX in is the UTXO which is actually going to be spent. The reference UTXO is where the script is. It's effectively the address of the script. Does that help?
Yeah. Yes.
Yep. I think that's right. Yep. So it's just these reference, so that it doesn't like James is saying, it could be, you could put it in the script itself, or you can put it in all these different places, but the UTXO model in CBOR fits in there in some way, that holds the code in that UTXO, in that address. And that's the reference thing. And is that the same reference? I mean, are we using it in the same way as SIP 25? Or maybe not. It's just this is just a reference transaction that has this policy, lots of words in there.
As SIP 68, which has the two different tokens.
Oh, right. Yeah.
This is 100% a pain point right now. Yes.
Yeah.
So we have the word reference UTXO that in the usage on Faizan's screen right here. Okay.
Yeah.
So on chain, we do have a thing called reference UTXOs that hold scripts that we might want to read. And I just threw these two phrases in the chat as well. I'm hearing people become more and more comfortable using the phrase deploy a contract, which feels like a reasonable thing that you'd want to do. Okay, I built a smart contract. I'm going to deploy it. When people say that, they're usually talking now about putting a reference UTXO on chain. Okay. And once that's deployed, you now have what many people are now referring to as a read-only UTXO. On line 101, we are reading but not spending a UTXO. And that's the critical distinction that Dan just made, right? And this was not a thing before November of 2022. or September. I forget. I always forget what month the Vassal hard fork happened. Late 2022, we first got this capability. So we're still only in the first few months of having it. Okay. All right.
Okay.
Now, back to this ambiguity that Newman was referencing. The problem is SIP 68 proposes pairs of tokens, one of which is called a user token and one of which is called a reference token. And that reference token is not the same thing as the reference UTXO we have here. So we need probably to use a different word when we talk about SIP 68.
Yeah.
To make matters worse, sometimes those reference UTXOs go in, sorry, those reference tokens go in UTXOs that it ends up being convenient to call those reference UTXOs as well. And just to joke around, but to tell you something true that you can probably find in this code base somewhere, I have found myself, according to the system that I'm using, correctly using the term reference UTXO, which doesn't feel very good. And we'll go back to that later if there's need to. But yes, there's frustrating ambiguity right here. And it's worth it to see these two different uses of that word.
Question, guys. Is it fair to think that this reference UTXO is like Cardano's way of imitating what like Ethereum and DVM chains do, that you deploy a contract to an address and then you refer to that address to interact with the contract? So am I right in thinking that you can use this reference UTXO to also send assets to that contract? Is that right?
Sort of, but not exactly. That's a really
then
question.
the contract will not be able to spend it, right? That would be a problem.
Right. Okay. So now there's also a little bit of ambiguity with the word deploy, right? You could also argue that forget about the reference UTXO and putting the script on chain. Okay. There's also, for a spending validator, you take your compiled Plutus script and you derive an address from it. And you saw this for the first time in module 101 when we built our first very simple Plutus scripts, and we showed how you take a Plutus script and you create an address. Right? And that's a key workflow. I could argue that the moment I deploy the contract is when I initially lock some funds now at that contract address. But locking funds at a contract and creating a reference UTXO, those are two different things. They do work in tandem. And so in that sense, right now, all of this information is on chain. So Claudio, I think you're right in that way, but there's nothing special about the address where I am storing my reference UTXO. Okay, so yeah, the contract address is what it is, right? That's derived algorithmically by building an address from a Plutus script. But the address that holds the reference UTXO is just it can just be a dumb address. It can actually be address of any kind, okay? But it doesn't become the contract itself. Now, there are cases where you might want to store your reference UTXOs at a contract address. You might want to give a set of users the ability to either change contracts given certain rules, or maybe you want a contract to never be changeable. You could send a reference UTXO to an unspendable address where it will be locked forever and always available. Harsha, what do you think?
Yeah, I have a pretty basic question regarding this. So any contract can create an address, right? It doesn't have to be a specific contract, right?
A spending validator can be used to create an address. Okay, but if I make like a minting validator, I think you still can derive an address for that. We should check. but it wouldn't be a spendable address because the validation logic is for minting rules, not for spending.
And can you can like a UTXO reference UTXO store Lovelaces, or is it only for contracts?
Great question. Okay, so actually a reference UTXO must store Lovelaces. Right, we know about the concept of a min UTXO on Cardano. UTXO has to have a minimum amount of Lovelace, but actually that number is much higher for a reference UTXO. Okay, a very simple transaction, the min UTXO is right around 1 ADA, right? A UTXO that has a lot of datum in it, the min UTXO could be almost 2 ADA. I think Mix was saying last week that he figured out that the very highest limit that you can even hit with datum is about 2 ADA. A reference UTXO with the Plutus script in it, it's in my experience, it's somewhere in the 10 to 30 ADA range. This is a really interesting thing. We say, I already said in this call, once you put a reference UTXO on chain, it saves transaction fees. But that's really only half the story. Because in order to get those transaction fee savings, whoever deployed that UTXO had to post, call it 20 or so ADA, right? To even place that information on chain. So I should only use reference UTXOs, one could argue, if there's going to be enough transactions that the savings exceed the amount of min UTXO that it took to deploy that thing. Okay. And we can look for this, up higher in this file, or actually it's imported where, oh, here it is. On line 19, Faizan, is the ref UTXO itself. Can you copy everything before the hash there? Just leave off the hash 0, yeah. And bring that over to Cardano scan preprod.
And now this gets exciting for me because I love just kind of using these tools just to be like, okay, what can you find out in these things? All right, I'm back in it. My brain was like, whoa, where's it going on now? I'm like, okay, here we go.
That's some deep stuff. And I expect that we will have to recover all of those points. That's okay. Right?
Yeah, okay, good.
Well, all of the 200 level modules are built to make space for these conversations to eventually happen.
Yeah.
But if you need to hear it 7 times.
Sure. And that was a great question, Harsha. Can any contract create an address? And it's like, no, that's the spending validator. And then that got us into all those things. Yeah. So this is good. This is really good.
All right. So first of all, look at this transaction here. Let's go down below. And what you see is actually the summary is boring. This is just a transaction where a fee was paid. And you can see the fee was 0.3, not quite twice the minimum fee.
Right.
We thought the minimum fee is like 0.16, 0.17. All right, so here we have 0.30. So what you can see is actually this was just a transaction where an address sent funds to itself. And that's because I already had, looks like there's a total of 145 test ADA in this transaction. I have an address that I've just been using for a bunch of different reference UTXOs on testnet. Okay. And when I need to create a new one, I also just keep extra Lovelace at that address so it's easy to deploy a bunch of different reference scripts. The UTXO tab is going to tell a more interesting story. So here you see one big UTXO was spent from this address. and two outputs were created. The first one is the reference UTXO. And the second one is the change.
Those two lines there, I mean, they're the same for the most part.
Yeah, same address,
Okay.
right? But different amounts.
Ah,
Right?
from address, where are the amounts?
Over on the left-hand side. Or sorry,
Oh,
the right-hand side. I got my left and right mixed up. The right-hand
oh,
side.
I was zoomed in. I was on the Zoom. I zoomed in. I was like, right.
Oh, I
here.
see.
Yeah.
So, right,
Oh,
so this
okay.
first output, this is a transaction. The wallet address is the same for the input and for both outputs. This is a transaction to the wallet itself, right?
Right.
But the first output is the one with the reference script, and you can see, look at that min UTXO there, 13.92992. That happens to be what the min UTXO is for this relatively small contract that we're deploying.
Okay.
And then we can look at the contract with that little orange circle there.
Yeah, what does that denote?
Effect. Let's try it. What does it do?
Ah. Oh, and then there's the big script. That's the stuff.
There's the CBOR.
That's the CBOR. Right. Okay. And we can copy that and post it into our hex converter thing, and then that will tell us, it'll make it readable-ish.
Great question. Well, in this case, since this is UPLC, untyped Plutus core, and this is the CBOR representation of that.
Oh, then
it wouldn't give us something beautiful in a hex converter, not like a token name would.
right.
Right. But yeah, there are ways to decode this for sure.
Okay.
Notice the type field.
Right.
Type Plutus V2. Hopefully for everybody that implies that, oh, maybe there are other types as well.
Right.
Right. And that's the number of types is limited for now, but someday there will be a Plutus V3 and a V4, etc. And maybe there's other types of information that you'd want to put on chain and make it read only. For example, some datum, right? So inline datum is similar to this, but not exactly the same.
Yeah.
Finally, there's a hash. This is not a transaction hash, right? This will not match the UTXO hash that we searched for originally. This is the hash of the Plutus script itself. And what a hash is, it's just a way of summarizing information. There will be a one-way function that it takes you from script to hash. And the same script is always going to give you the same hash.
Right.
But there's no way to work backwards, right? You're not able to decode a hash back into the original script. What you can do is you can search the blockchain for a given hash.
Okay.
This is interesting because services are starting to pop up that give us convenient tools based on this functionality. For example, some people saw the Go Maestro presentation at Gimbal Labs Playground a few weeks ago. Maybe you've investigated Maestro on your own. Okay, gomaestro.org. And what they've done is they're not just giving us what like GraphQL gives us, raw data. They're providing some services that actually refine the data a little bit along the way and make it more usable. Or they index the data in innovative ways to give us different sorts of endpoints. And one of the Go Maestro endpoints allows you to find the reference UTXO for a given hash on chain. And this is a convenient thing. You might know the contract that you're trying to reference, and maybe you're thinking, well, you know, if somebody else has deployed this before, I don't want to spend my 13.92 ADA. So what you're going to be able to do is, knowing the hash of a contract, query the blockchain for that hash. And hey, if you find the reference script you need is already there, just use it. There's no point. If you deployed your own, the only thing you would gain actually, I shouldn't say there's no point. What you would gain is that you would know that you are in charge of spending that reference UTXO, right? Because you can actually crash an application if you spend this reference UTXO. So it's no longer accessible, right? And this address right here that ends in 77S, it's just a very basic Cardano CLI address, just like you learned how to build in module 102, right? I have the payment key for it. So if I wanted to just make everything not work, I could, or if I accidentally spent this UTXO here because I forgot that it had a reference script in it, this bash script we're looking at wouldn't work anymore. But that's a good thing. We want these to be spendable because we want people to be able to reclaim their ADA, right? And if a script is no longer useful, we should be able to take it off the chain.
Oh, wow. Wow. Okay. It's like the brain. It's like I'm in the Tour de France, like going up and down the mountain. It's sort of like, oh yeah, I get it. Oh, I see. I can tell. Okay, and right back in the ground, right back to grinding it out. Hey, Faizan, is this sort of in your zone? Are you feeling it? Like, are you learning more about this sort of the what you need or to get through, or can we recenter over there?
No, it's like just heavy words getting in the mind and learning a new things and getting information from what we can achieve through these addresses. What all we can do.
Yeah. I feel that, like all these different things, and it's inspirational in a way. But I also know that we're working through the course, and this is the time. We've got everyone here. Is there things that you want to ask? You want to pull us back in, and we got James and the gang.
I have a quick question before that. So hash seems like something that cannot be decrypted. I think that's the opposite of encrypted. So if there is like a hash and then a CBOR which can be decrypted, so wouldn't it isn't the purpose lost?
What?
Good. You're right with the definitions. In this case, in this use case, having the hash of the contract doesn't help us in any functional way, so it's kind of hard to demonstrate. Okay, so in this case, yeah, what we really need is we need to validate against the CBOR. Right? You can know the hash of the contract, but that doesn't give you access to the contract logic itself.
Okay. But the CBOR does, right? If you know the CBOR,
exactly.
Okay.
And that's why it's on chain, right? That Faizan, can you tap that orange button again? Right. This CBOR to a machine is exactly the same as the Plutus code itself, right? It's just the kind that is most efficient to transport. But all of our validation logic is usable from this CBOR script right here. Can we look at actually the Minter validator for a second to switch gears? Right. So I just dropped in the chat the Plutus code for the CBOR that we were just looking at.
Plutus code for the CBOR we were just looking at. Okay.
Yeah.
Minter.hs.
Okay. And this is all in one file except for the compilation step. Okay, but look at the signature on line 37. All right. One difference, maybe this is the first time you're looking closely at a Plutus minting policy. Okay. One thing I'd like to share is that there's no datum in a minting validator, just a redeemer and a context. And so on line 37, where you see make policy and then policy params and then token name is the redeemer. Context means the same thing it always has, right? It's the information about the transaction that we are inside of right now. And in this case, we are including parameters, but that part's optional. Policy params would not be required to write a really basic minting policy. Just redeemer and context. What are those params? Well, those are up on line 27 through 30. What's most important here is line 28. Okay, so in these params, we're just supplying the policy ID of your contributor token so we can look at it. Okay. The validator, I don't think we actually use it in this file, and that's just there, just in case we want to do some fun things later on. Okay, so we're going to ignore line 29 for now and just say, all right, there's another parameter there that you could play with. But line 28 is critical and we're going to use it. Back to line 37, token name is a built-in Plutus type. All right, so we're not defining that in some other place, just like currency symbol and validator hash and script context, token name comes out of the box. It will be the very same to use integer right here. That's another built-in type we can have. And if you scroll down to the bottom, you can see where. Oh, sorry. No, I'm still, well, yeah, you can see the wrapped policy, but Plutus is changing and I still have some old habits. Yeah, on line 83, you can see how we go from token name to built-in data. So we keep policy params the way it is, but then built-in data, there's our token name and our script context. And we wrap a unit because that's this step on lines 83 and 84 is taking us one step closer to untyped Plutus core. Okay. All right, but that's a little bit of a detour. I thought we would see token name down here. So Faizan, can you zip back up to line 37? And let's just look at this logic. Let's go line by line. So we have these three inputs, params, token name, and context. We give each of them a name on line 38. Those names are arbitrary, underscore param, underscore TN, underscore CTX. Those are just variable names. And then we say, okay, we're going to do a few things. First of all, we're going to let info be the TX info. If you've been looking at validators, maybe you're starting to notice that lines 40 and 41 are boilerplate. Okay. We're usually going to be interested in the TX info from the transaction in question. Then lines 43 and 44 is just a little helper function. This says, give us all of the value spent in the TX info on line 44. Okay. And return that as value. Okay. basically this says, yeah, give me a list of all of the inputs in this transaction. And then on lines 46 and 47, we also look at all the values spent, and we just make a list of currency symbols that are in the inputs. And then on lines 53 and 54, we use invals. You see at the end of line 54, it says param element invals. Okay, so invals was defined on lines 46 and 47. What is it? It's a list of currency symbols. This ELEM element is a built-in Haskell function. It has those little backticks around it because that's how Haskell allows us to inline a function. And there's, I don't want to get too lost in inline, but it's a helpful thing. If I say 3 plus 2, that's going to sound familiar to a lot of people, right? But technically, if you want to write an addition function in Haskell, the proper way to use the function would be to write plus 3, 2, right? What's the function? It's addition plus. What are the two parameters or inputs to that function? They are 3 and 2. And that's how Haskell works in general, but sometimes it's just hard on our eyes to look at it that way. I would much rather be able to say 3 plus 2 than have to say plus 3, 2 every time. And so you can actually make inlineable any function if it's helpful to your brain. And that's what's being done with element here. What I could have written is LM at the start of the line, exactly, Faizan, right? Contributor token policy ID param invals. But that would be really confusing to look at. Semantically, the question I want to ask is, hey, is the contributor token policy ID from the parameters an element in invals? Now, up at the top of the page, one more time, if you could scroll up a little bit, I want to still be able to see line 54 if possible. Yeah, but then look at line 28. What is the contributor token policy ID? What's its data type? It's a currency symbol. It's defined right there on line 28. What is invals? It's defined on line 46. It's a list of currency symbols. Can you see the logic, right? So we're asking the question, hey, is this single currency symbol an element in this list of currency symbols?
Okay.
So far, so good.
Wait a minute, where is that? Where is that logic? Where is the, I see that the contributor policy token ID on line 28 is a currency symbol. And I see that invals is a list of currency symbols on line 46, but where is it? Where are those?
Now that we've set those two things up,
Yeah.
line 54, we ask the question.
Input, contributor token policy, param, elm, invals. Huh. Maybe I don't know that. What is?
Okay.
I think we are just looking the currency symbol. Is that currency symbol is in that list or not?
Okay.
This
Param.
element works like that. It just searches the element currency symbol is in that currency symbol list.
Okay. Yeah.
This is harder to read because of the param part too. Faizan, can you just highlight contributor token policy ID param on line 54?
This one.
Just the part that says contributor token policy ID param. Yeah, that bit right there. It wouldn't change the Haskell to just put parentheses around this, and this might make it a little bit easier to read.
Okay.
Okay. And basically this part, what's param underscore param is defined on line 38 as the name of what? As the name of the policy params we're passing here.
Oh.
What's policy params? It's defined on line 27. It's got two things inside of it. This is called a record, by the way, on lines 27 through 30. This
Okay.
record has two fields in it, just like a form, right? A Google form could have many different questions on it, right? A Haskell record can have many different fields inside. This record has two fields, contributor token policy ID and NFT validator. And we define the types for each of those as well. But if I want to look inside of a record, the syntax looks like what's highlighted on line 54. I put the name of the record last and the thing I'm looking up in front of that. So let me try reading line 54 again.
Okay.
This says, look up the contributor policy, look up the contributor token policy ID in the policy parameters. And whatever currency symbol you find there, check that it's an element of invals.
Right. Okay.
If it is, there's two answers to that question. Yes or no, true or false.
Yeah, there it
That's
is.
why line 53 is able to simply return a Boolean. Everything after the equal sign on line 54 is just true or false. This is where I think Haskell starts to get beautiful.
Yeah.
I have this long statement, contributor token, param, elem, invals, yeah. But what is it? Well, it's just a Boolean. It's just a question that has a yes or no answer.
Nice. Oh, and now I'm looking at the comment. Check that the input has the PBL 2023 token. Okay, cool.
Like it says here, this is redundant actually.
Yeah.
But we didn't want to just throw lines, the next few lines at you. Okay. So let's skip over lines 57 and 58 for a moment and come back to them. But let's look for just a second at lines 62 through 70. This is the part that makes the lines 53 and 54 redundant. Okay. But it's a little bit more complicated. Here we say, okay, we'll start with a comment first, right? We're going to check that the redeemer matches the token name of whatever PPBL 2023 token the student trying to mint is supplying. This is an extra layer of check. So now we're ready to zoom out and think about what this minting policy does in the first place. Okay. And this is going to finally take us full circle to why we're able to create more interesting minting policies here. What we're trying to do with this contract is allow anybody who holds a PPBL 2023 contributor token to mint a PPBL NFT. But there's two parts to this logic. One, you got to have the PPBL contributor token. Two, given that you hold that token, you're only allowed to mint an NFT with a matching name. You can't, if you have a nasty honey badger contributor token, that's the only NFT you're going to be able to mint.
It's the only one that I want to mint, actually. That's the best one. It's the best one.
All right. Now, before we talk about the specifics of this logic, and I think we have just enough time, 10 minutes, to really just take a high level view of these. I want you to zoom out even more. Forget about the Plutus part. Can you imagine that it's useful to be able to allow the holders of one token to mint other specific tokens?
Sort of downstream tokens or
Yeah.
token.
Ooh, you're in the system. You have this contributor token.
Yeah.
We're going to let you mint this or that.
Once you've achieved this, it's a kind of like the game unlock. You got achievement. There's a badge. You get an unlock, and now you can do these things. Yeah.
Ah, what if I added to this logic right here another check of your contributor reference datum, the datum that says which modules you've mastered in the course, and depending on your mastery, you could get a silver, gold, or bronze token from there, right?
Right.
Yeah, we could do that. We could add that. This is only checking that the name matches for now, but exactly. We could take this one step further and mint specific tokens based on people's achievements.
And taking a step even further back, that the reason to have this on the blockchain is that so that the teacher can't, like, it's your own, there's the beautiful ownership, immutableness of it. Like it's not siloed in something. So there's the sort of relative advantage, like why to do this in Web3 as opposed to Web2.
Exactly.
And
Can't stop
that
anybody.
yeah. What's that?
Can't stop anybody.
Yeah,
Right?
yeah.
I've met a few teachers who, they might fudge the grades in their grade book depending on who they like more.
Exactly.
Right? It's a human tendency. We're not going to judge anybody for doing that. Let's just recognize, hey, people do that.
And fudge in the positive and in the negative. It's just like
bingo. Nope. So we can build a system where that's not possible. Right? Hopefully we end up liking each other, but I mean, it's not a requirement of the system.
Yeah, it's totally true. It's totally true. And that it operates like with having all the scripts on chain, like the references, like what we were talking about, then it kind of operates in that sort of zone. Like there's a
Now come all the way back to the start of this session and compare this to using a native script. A native script says, hey, if it can be something really simple, but it's usually going to involve a pub key hash. Right? That's really what native scripts allow us to do, is to protect minting with somebody's signature. Right?
And okay, and native script versus Plutus script. Okay, and the native is just native Cardano.
Yeah. You'll see this is a good chance to also revisit in the course. This is module 202. Okay, so in module 202, you're going to see a variety of different ways to mint a token, and you'll see a native script. So you can A, see what it looks like, and B, see how to use it. Okay. But think about this. If I make a native script, and we can go review those. Maybe we do that tomorrow. But if I make a native script and I want other people to be able to mint with it, I got to pass my signature around. And that's one of the cardinal rules, that we don't do that. Don't send your signature across the internet. That's like putting your mnemonics on Twitter. Okay. So we wouldn't want to do something like that. So look at what else is going on here. Because we're using Plutus and more robust logic, it allows people to mint NFTs with the same policy ID without any reliance on a particular signature. There's no checks for signatures here, just for ownership of a different token.
Uh-huh. So, and then that ownership of a particular token is scalable. It's like, you know, like what we're doing with the Zoom. Like, wouldn't it be great if Zoom, like, well, anybody that has this token now can open up the contract to start the Zoom. We'll get there. Integration with the Zoom might be the thing.
That's so CMOS has been working on that. What he presented at town hall maybe a month ago with token authentication, he started building that because he wants to achieve that functionality with Zoom. We're getting there.
That's right. That's right. Okay, that's making sense now. All right. Yeah, as a service, it's just like, okay, we can do, okay, yeah. Ooh, Lord. And you're
we can have this exact same conversation again. And
yeah, I hope so.
We can each be noticing different things each time. This is where we're going. Okay, but we're really, I'm so excited. Thank you so much for this conversation, guys. Can we do a 3-minute jam on the logic here, just to look really just briefly?
Sure.
Think about how it works. Okay. So first of all, let's now focus on lines 57 through 60 for just a moment. All this says is you can only mint one token at a time. Right. That's really what this does. Right. So again, 57 check minted amount. It's a Boolean. What are we looking at? Okay, we're looking at TX info mint info. Info is just the transaction info defined on line 40, right? And transaction info has a bunch of different stuff in it. On line 44, you can see that info has a value spent field in it.
Okay.
On line 58, you can see that info also has TX info mint in it. And compare this, remember earlier we were talking about the record type for the parameters, contributor token policy ID underscore params. The syntax here is exactly the same, right? On line 54, we say, get me the contributor token policy ID in the params. On line 58, we say, get me the TX info mint in the info. And without going too deep into what TX info mint is, just recognize that it's part of the info in the transaction. We have a helper function here called flatten value. And we're not going to go deep into all the details of this syntax right here, just for lack of time. But just notice all this says is, hey, look, if this token exists, right? If you can find that any tokens were minted, first check that the token name is equal to the token name we expect. You see underscore TN, that comes from line 38, the token name that was passed as the redeemer. Right? So we use the redeemer to pass the expected token name. And then we check that indeed that token name was minted in this transaction. How many times was it minted? Once and only once. It's an NFT.
Okay.
If anything else is true, if nothing in the transaction is minted, or sorry, nothing is minted in the transaction, right? Or if more than one token is minted, or if it has the wrong name, false, don't do it.
Yeah.
Don't mint it. Okay. All right, and we're at time, so we won't even, I'm not going to try to squeeze check token name into 19 seconds. But again, like practice, like try reading these functions out loud and see how it feels, even if you don't feel ready for it yet. Okay.
Yeah. How is ChatGPT with this?
I haven't seen that it's there yet, but I haven't checked in a while. And it's you know, it's going to tell us, you know what? It's going to tell us more about how fast the Chat GPT data is updated than anything to know
Right.
how it's improving right now.
Check it out. That's great. That's, I mean, these code walkthrough is just, it's like a super great thing to do. Yeah. So we're wrapping up.
We
Closing
are.
thoughts?
I see, Claudio, your request in the chat. I'm going to get that link right now and drop it here before I forget. In the documentation, this is easy to find. Documentation. It's the blockchain indexer, and it's script of a script hash. So here's the direct link in the docs to what I was talking about before. Go Maestro has a blockchain indexer, and one of the endpoints they provide is the ability to get the script for a given script hash if it exists on chain.
Cool.
Yeah. Y'all, feels good to be back here. I'm going to be just working regularly for this and the next 2 weeks after this. So like a 3 weeks stretch of deep work, 6 consecutive live codings where I'm excited to just do this. Then keep in mind, we've got Gimbal Labs Carnival kicked off yesterday. We didn't do any official sessions. I just kind of shared the idea and gave people a way to get into it. And I'll post a video about that on the Gimbal Labs website later today. But if you're interested, save the date for next Tuesday, 1800 UTC. We're just going to read the Hydra docs together and see if we can get something to work.
Nice.
When it comes to Hydra, I'm a beginner. I'm just going to be reading it for the first time, but I figure it'll be fun just to try to do that in public and see what happens. Okay. And then the week after that, Matthew Ploman, I think he's at IO right now. He had a question about chaining transactions together. So we recognize that when you build a transaction, the transaction hash is calculated before the transaction is actually verified on chain. So if you already know an output transaction hash, but it's not available for spending yet on chain, how can you build a system that allows you to place dependent transactions in time, so that as soon as transaction number 1 is done, now we try to fire off transaction number 2, sequential transactions. So we're going to look at that 2 weeks from now at the Gimbal Labs Carnival.
Hey, what's the link for the Gimbal Labs Carnival? I had one and now it's 404.
Oh, I took the word summer out because it was, it was preferencing the Northern Hemisphere. Now it's just Carnival 2023 instead of Carnival 2023.
Oh, yes, I like it. That's really great.
It felt good. Summer Carnival was really rolling off my tongue, and I was like, well, we're ignoring half the world right now, so let's try not to do that.
Change it up. I like it. That sounds great.
Mm-hmm.
I was listening to someone on YouTube, and it's yeah, I'm stoked for the summer carnival, for the carnival. Cool.
Good things. And yeah, at that link I just shared, I'll drop the recording from yesterday shortly.
Nice.
Any other last words? Cool.
At the bottom of the mountain, I feel small. At the top of the mountain, I feel big. It's from this old, basically an old school French cyclist, Pinot, and he's probably going to be in his last tour coming up here. But there's a great Netflix documentary on the Tour de France if you ever wanted to learn about it. It's good.
That's beautiful. Combine that with standing on the shoulders of giants, and you've got, a whole
got a whole thing. Yeah. Well, that's what I feel. That's what I feel like. There's this thing of like looking out at this big, effort and saying, wow, I feel really small. But these little mountains that we climb together, I feel really big. You're like, oh, I can understand. This is a doable thing. Like these mountains can be moved, and we can climb them, and then we're climbing them together. It feels great. Okay, we'll see y'all tomorrow.
Thanks.
Ciao,
Take
y'all.
care.
Tomorrow.
See you soon.